Welcome students. In this video we shall see problems on stress and strain. A square steel rod 20 mm into 20 mm in section is to carry an axial load of 100 kN. Calculate the shortening in length of 50 mm. Young's modulus is 2.14 into 10 power 8 kN per meter square. So a rod is given, the length is 50 mm. When you cut a part of it, that is the cross-sectional area will be a square shape with 20 mm into 20 mm. So the area is 20 mm into 20 mm, length 50 mm, Young's modulus 2.14 into 10 power 8 kilonewton per meter square. To remove the kilo, you have to multiply by 10 power 3. So 10 power 8 into 10 power 3 will give you 10 power 11. 2.14 into 10 power 11 Newton per meter square. The force applied is 100 kilonewton. So to convert the kilonewton into Newton, you multiply by 10 power 3. In this sum, you have to find the change in length. We know that strain is equal to change in length by original length. Strain is also equal to stress by Young's modulus. Stress is given by force by area. Force is 100 kilonewton or 100 into 10 power 3 Newton, and the area is 20 into 10 power minus 3 into 20 into 10 power minus 3 meter square. See, area is equal to 20 mm into 20 mm. To convert the mm into meter, you are multiplying 20 with 10 power minus 3, and here you have 10 power minus 3. Therefore, I will be getting 20 into 10 power minus 3 into 20 into 10 power minus 3 meter square. And the Young's modulus, this value is in Newton per meter square. So make sure that the numerator and denominator are having the same units. So if you solve this, you'll be getting 1.16 into 10 power minus 3. Here there will be no unit. To find the change in length, you have to bring this L on the right hand side. So if you substitute the length in mm, you'll be getting the change in length also in mm. So the change in length is 50. You multiply 1.16 into 10 power minus 3 with 50. Finally, you will be getting 0.0584 mm. So this is your final result. The next problem, a hollow cast iron cylinder 4 meter long, 300 mm outer dia and thickness of metal 50 mm is subjected to a central load on the top when standing straight. The stress produced is 75,000 kilonewton per meter square. The Young's modulus of the cast iron is 1.5 into 10 power 8 kilonewton per meter square. So you have to find the magnitude of load, the longitudinal strain, and the decrease in length. Since you are applying a load, compressive stress will be acting and there will be a shortening in the length. So the length is given 4 meter and the diameter is given 300 mm. So you convert it into meter. So divide by 1000, you'll be getting 0.3 meter. And the thickness is 50 mm. So you have to convert it into meter by dividing by 1000. The stress produced is 75,000 kilonewton per meter square, and the Young's modulus is 1.5 into 10 power 8 kilonewton per meter square. So you have to find what is the load, what is the strain, longitudinal strain, and what is the change in length. This is your inside diameter, and this is your thickness, and this is your thickness. The total is capital D, outside diameter. So this small d plus 2 times thickness is equal to capital D. From this equation, you can find what is the inside diameter. I know what is the outside diameter and what is the thickness. From this, I can find what is the inside diameter. So the inside diameter comes around 0.2 meter. We know that stress is equal to force by area. We know what is the stress and also the area can be calculated. From this equation, we can calculate what is the load. So force is equal to stress into area. The stress is in kilonewton per meter square and area is in meter square. So you multiply both these values, 75,000 and area. Area is pi by 4 d square minus d square. See, you are having a pipe like this, hollow cylinder. The load will be acting on the hatched area. So the area of the hatched portion is pi by 4 d square minus d square. That's why the area is given as pi by 4 into capital D square minus small d square. We know what is capital D and what is small d. We have to substitute these values and finally we will be getting what is the load. So load is 29.2945.2 kilonewton. So how this kilonewton came? That again depends upon the value you are substituting. Since the stress is in kilonewton per meter square and the area is in meter square, so when you multiply both these terms, meter square gets cancelled and the remaining will be kilonewton. Now the strain has to be calculated. Strain is equal to stress by Young's modulus. This is from Hooke's law. So strain is equal to stress by Young's modulus. We know what is the stress and Young's modulus is given as 1.5 into 10 power 8 kilonewton per meter square. So you divide both the values. The strain will be coming around 0.0005. Next you have to find the change in length. Strain we have calculated, then we have to calculate the change in length. The relationship between strain and change in length is strain is equal to change in length by original length. So from this I can get what is the change in length. So change in length is equal to original length into strain. The original length is 4 meter and the strain is calculated as 0.0005. So if you multiply both these values, you'll be getting 2 into 10 power minus 3 meter. So how you are getting this meter? Because the length is substituted in meter only. That's why I am getting the change in length in meter. So to convert this into mm, you have to multiply by 1000. So you can multiply this value with 1000 to get in mm. So the change in length, strain and load has been calculated. Thank you.